Hello everyone, thank you for joining my tutorials. You are listening to Vikas Ghadamude. Today we are going to learn how to calculate land surface temperature using Landsat 8 data. To calculate the land surface temperature, we have some formulas that we are going to apply to calculate the land surface temperature. First we will calculate the top of the atmospheric radius. This is the formula for calculating the top of the atmospheric radius. L lambda is equal to ml into qcal plus al. So L lambda means top of the atmospheric spectral radiance, and ml means radiance multiplicative band, and al means radiance add bands. So qcal means quantized and calibrated standard product pixel values. Mostly this is the formula that we are going to use to calculate the land surface temperature. It's very simple to calculate the land surface temperature. We have certain formulas that we are going to just add some bands or anything else that you can easily calculate the land surface temperature. So the top of the atmosphere brightness temperature then we will calculate. So BT will calculate. This is the formula K2 divided by Ln in bracket K1 divided by L lambda plus 1 minus 273.15. So here is the top of the atmosphere brightness temperature. Then K1 and K2 value we have that will get from metadata. So all these values, all these BT, L lambda, all these values are in metadata of Landsat 8 that will get from downloading a Landsat 8 data. When we will download the Landsat data, we will get all this data. So then we will calculate the normalized differential vegetation index, NDVI will calculate. So for calculating the NDVI, we need a band 5 and band 4 of a Landsat 8 data. So band 5 is our near infrared and band 4 is our red band. So NIR minus red that we are going to use. Then we are calculating the land surface emissivity. So for calculating the land surface emissivity, we have formula for the PV. PV means proportion of vegetation we will calculate first. So for the proportion of vegetation, there is a formula NDVI minus NDVI mean divided by NDVI max plus NDVI mean, its squares. So mostly this is the formula, and then we will calculate E mostly. So all this formula, E is equal to mostly land surface emissivity. E means land surface emissivity. So it's 0.004 into PV plus 0.986. So this is the formula that we're going to apply. Then last one is the land surface temperature that we are going to calculate mostly. The land surface temperature is a last step. First we'll calculate all this, then we'll calculate the land surface temperature. So BT means that is the top of the atmosphere brightness temperature that we'll calculate. Then watt is W means wavelength of emitted radiance. That we have all the formulas that we are going to apply, and it's very simple to calculate a land surface temperature. You can I will tell you in a very simple way, and you will able to understand it. You just give your concentration for a few minutes. So we have a data of a Landsat 8. So this is 11 bands. So these 11 bands we have downloaded from the USGS Earth Explorer. Means we have downloaded its. You can go to USGS Earth Explorer. You can add coordinates, or you can show address places. Then you can go to dataset. In dataset you go to Landsat. In Landsat collection level 1 you go, and in that Landsat 8 OLI or TRS C1 L1 you select, and then go for the result. When you will go for the result, you choose an area which having a very less percentage of cloud is there. Means we are calculating the Landsat, so mostly we are going to click here for download, and it will automatically download it. After the downloading data, we will open it into the ArcGIS. So for opening this into ArcGIS, we will go to add data option. In add data option, I will add a band number 10 is there. So this band number 10, I am using this 2020 data. So I am going to add this band 10. So after downloading the data, if you want to, you have to extract the file mostly. So after extracting, you will get all this band. For that, suppose if you have downloaded the data, and after downloading, you will get this kind of file. So this file you have to extract. When you will extract, it will show like this. After extraction, you will see all the 11 bands. So we want thermal mapping band 10 and band 11. So band 10 I am taking here for calculating the land surface temperature. I am adding here. After that, what we will do, we'll apply all those formula that we have seen just. So for that, we'll first calculate L lambda is equal to ml plus q cal plus al. This is the formula. So ml means radiance multiplicative band. So this radiance multiplicative band will get in metadata. Metadata it shows in MTL format. So what we're going to do, we'll right click and we'll open this metadata into Word format or WordPad. So after that, you can able to see this is the metadata. In metadata, or metadata means data of data, we call it as a metadata mostly. So this is the path and row is showing here. This image is taken, acquisition date is 2020-4/21, and this is time is given below. So what we want mostly, we want radiance multiplicative band value we want mostly. So this radiance multiplicative band 10 I am showing here. So in radiometric rescaling there is a radiance multi band 10 option is there. So this we want, and radiance add band 10 option is there. These two things we want for calculating L lambda. So we'll go to ml into qcal plus al. So ml I have just shown you radiance multiplicative band. So this one is a radiance multiplicative band number 10, and then qcal means our band number 10. So this band number 10 is our qcal, and al means radiance add band number. So this is also shown, I have shown you. So now we'll go to ArcGIS, and in spatial analysis tool, map algebra raster calculator tool is there. In raster calculator, first what we'll do, I will show you. First we'll add here a value of our band 10, that is ml. So radiance multiplicative band value first we'll check. Okay, so this value I have shown you, this is 3.1420 e minus 04 is showing. So we'll convert it 0.00040 we have to add, then 3342. I will cut this from here and I will paste it into raster calculator. So first I have taken value of ml into, so I am showing formula above. So again I am showing ml into qcal plus al. So qcal I told you it's a band number 10. So into our band number 10 plus al. So this is the symbol of plus al. Al means our 0.1, that is I have shown you a radiance add band 10, that is 0.1. So we have added all radiance multiplicative, then our band number and this, then we are going to save it in a new folder. So for that I will create some new folder. So let me create it into desktop. So I will go to desktop and I will add as a new folder, and I will give as a LST, but LST already is there. So what we'll do, we'll give some another name. We'll go to add new folder, and I will give name as a LST, land surface temperature, or land ST. So in that I will save as a radiance 10. What we are doing, we are calculating radiance. So I am giving here as a rad 10 or radiance 10. So I will save it and I will press OK. Now process is going on in background. We'll see in geoprocessing result. Now you can able to see our radiance stain is created here. After that, what we'll do, we'll go and we'll calculate brightness temperature. So first we have calculate L lambda, then we're going to calculate top of the atmospheric brightness temperature will calculate. So this is the formula K2 divided by Ln in bracket K1 divided by L lambda plus 1 minus 273.15. So K2 and K1 value is given in metadata. So we'll go to metadata. I will show you the value of K1 and K2. So this K1 constant and K2 constant band value is given there. So K2 value you can able to see 1321.0789. So I will copy it from here, K2 value, and we'll go to R toolbox. Raster calculator option is there. In that I will paste K2 value, then divided by our ln. So we'll take ln from conditional tool. So here is ln. After that K1 we want. So the K1 value is given in metadata, from where we'll take K1 value. From here we'll take K1 value. I will copy and I will paste here. After that, divided by L lambda means our radiance 10. So this radiance 10 I will take, and plus 1 minus 273.15. So what we are going to do, we have add this formula and we are converting this Kelvin to degree decimal. We are converting this Kelvin to our .273.15. So after that we'll save this. I will give bracket to it. We are converting into degrees, so this Kelvin value, so that's why we are giving 273. So I will give as a BT 10, so brightness temperature 10, and I will press yes, OK. So now my brightness temperature map is ready. So you can able to see temperature there. Now our third step is to calculate normalized differential vegetation index. NDVI will calculate. To calculate the normal vegetation index, we need a band number 5 and band number 4. So band number 5 and band number 4 will take, and this is the formula NIR minus red divided by NIR plus red that we are going to use to calculate our normalized differential vegetation index. So for that I will go to add data and I will add band 5 and band 4. Add option is there. So this is the formula NIR minus red divided by NIR plus red. We'll add float first. Here we'll go to raster calculator. So we want in, we'll take float. So here is the float. Then NIR means our band number 5 minus or band number 4 divided by float band number 5 plus band number 4. I will give name as a NDVI. I will save and OK. So our NDVI map is ready. It's showing -1 to +1 range. I will give color to it. So NDVI is -1 to +1. So higher value of NDVI refer to healthy and dense vegetation. So this green areas, higher value, is just showing healthy and dense vegetation, whereas a -1 value, it shows a sparse vegetation is there. So the minimum value and this one is a maximum value. So higher value of NDVI refer to healthy and dense vegetation, lower NDVI value shows a sparse vegetation. So our NDVI is ready. Now we are going to calculate PV, proportion of vegetation, and land surface emissivity we are going to calculate. So for that, this is the formula PV, NDVI minus NDVI mean divided by NDVI max plus NDVI mean, its square. So this formula we are going to use. Now we'll go to ArcMap. So this is the formula. You can able to see again. I am giving some time and to see this formula. Then now I am going to raster calculator. I will add NDVI first. First I will take square of it. Okay, because there is a square of this formula. So I will add bracket NDVI minus NDVI mean. So minus plus will be there. So -1 NDVI is there. So NDVI mean is -1. So minus plus. So I will take 1. After that, divide. NDVI max means our NDVI max is 1. First I will take bracket 1. So plus NDVI mean is there. So I will take 1. I will close bracket and I will give output raster as a PV. Again I am showing NDVI minus NDVI mean divided by NDVI max plus NDVI mean and its square. So we have to the same process. Then I am adding as a PV plus. Okay. So now proportion of vegetation, our map is ready. We'll change its color. Later on we'll go to calculate E. E is our land surface temperature. So for that 0.004 into PV plus 0.986. This formula we are going to use to calculate E. I will go to raster calculator. 0.004 into PV plus 0.986. I will add as a E and save. OK. Now land surface emissivity is map is showing here, so I will uncheck this. So now our last is to calculate land surface temperature. So for calculating the land surface temperature, we have formula for this: LST, brightness temperature divided by 1 plus W. W means wavelength of emitted radiance, that is a 10.8 for Landsat 10 band, then BT divided by 14380 into ln E. So E is our land surface emissivity. This formula we are going to use for calculating the land surface temperature. So in raster calculator, BT, brightness temperature 10, that we calculated before, then divided by 1 plus W. W I have shown you 10.8. We'll add first bracket, again showing the BT divided by 1 plus W into 10.8 into, again in bracket, BT divided by 14380. I will close the bracket into ln E. So this formula we use. I am also showing above the same formula. I will close the bracket and I will give name as a land surface temperature. I will save. I will press OK. So this is our final output of a land surface temperature. I will give color to it. So I will close all this, and it's showing a minimum temperature is minus 125 degrees Celsius, but it's not in the image, it's something outside. So this is outside of the image, and its border that it is showing mostly minus 125 degrees Celsius, but it's error due to the error in the image, because of that is showing. So what we are going to do, we'll calculate or we'll extract the area of interest. So I am going to create a new shapefile for that, and I will extract my study area from it. So whatever study area you extract it, then it will show correct land surface temperature. I will take study area, I will create as a polygon, and geographical coordinate system world WGS 1984. OK. So I will go to edit. Study area, continue. Feature, create feature. I will create a polygon here, means my study area. I am creating here. This is my study area. I want to extract this area, so I will save it and stop it. I will hollow this. So now we'll go to our toolbox, spatial analysis tool. There is a option, extraction option is there, and extract by mask. Extract by mask in input raster will give LST, and feature mask data will give as a study area, and I will give as a extract study area. So now we extract our study area. We'll close this and I will color it. Now you can able to see, and highest temperature 64 and lowest is 24. So if I will show you by identity tool, so first I will close this polygon study area, then I will show you. So red color shows a 27 degrees Celsius. You can able to see in red area in the image showing a lowest temperature, and green color index I choose for green, it's a higher temperature. You can invert it, no problem. So now our map is ready of land surface temperature. So it's very simple to calculate land surface temperature. So thank you for watching my video. It's very simple and very easy. You can also try. We'll meet in the next video. Thank you.